10, they give us y is equal to x squared minus 4x. Now we know this to be a parabola that's shifted over a couple of units to the right.
You forgot. Never mind.
And they want the tangent line, the normal line of this equation when x equals 1. All right? So here's what we want to do. All right? We're going to, first let's graph the function to get an idea. Now this is a parabola, right? We should know these functions by heart, right? So I'm going to say x squared minus it. Yeah, it's doing it by itself. It'll fix itself. And I'm going to graph it. All right, so it's shifted over a little bit to the right and shifted down. And what we want to know is we want to know when x equals 0, what is the tangent line right here? So what Mr. Adams is going to do is I'm going to over to the side here, I'm going to sketch this graph. We'll do it on the calculator, but I just want a visual reminder of what this thing looks like so I can have a good idea of, just in case I make like a math mistake or something, I'll know what I'm working with. So basically, and the point of interest is right here when x equals 1. And so when I go to draw my tangent line, boy, I kind of did a really bad job on the graph when I drew it by hand. But this is the tangent line, okay? So that's the tangent line. I'm going to need an equation for that bad boy. And then the normal line is a perpendicular bisector, or not bisector, but it's a perpendicular to the tangent line. So I'm going to draw another line that goes like this. And so that's the normal line. Okay? And they should form a 90-degree angle, and they're going to intersect at x equals 1 at this point here. And so when x equals 1, what is that, -3, I think it is? Yep. Let's double check here on the calculator. Yep. So it's 1 comma -3. So that's a point. Both, and think about that for a second, both the normal line and the tangent line are going to intersect at 1 comma -3. Any questions about that so far? All right, so now what I really need to form this tangent line is I need to know what the slope of the original curve is at x equals 1. So that is the challenge. So how do I do that? Well, remember that we can find the slope, which is really the rate of change, by taking the limit of the function f of a plus h minus f of a. Now all this stuff right here is just to find the slope. We should be in courtesy mode, by the way. All of us should be in courtesy mode. Thank you. We should all be focusing on this because this is basically the majority of our class for the rest of the year is how to take a derivative and then how to find the antiderivative, which is this process backwards. So the more we pay attention to this, the better we'll do later on.
So this is like what we're going to do for the rest of the year?
Yeah, I'll show you a shortcut later on, but yeah, this is the gist of it, okay? So now here is the trick. F of a, and let me write this over to, well, what is f of x? Well, we said that f of x is really the same as y, which is x squared minus 4x. And so, but I don't need f of x. I have a plus h and a. Well, f of a is easy. Wherever there's an x, I'm just going to plug in an a, right? That's easy. But now here's the question that's a little more challenging. How do I write f of a plus h? Well, wherever there's an x, I've got to plug in a plus h. Do you see how I did that? Does that make sense to you guys?
Yep.
So when I go to take the limit of this stuff, if I say the limit of h, a limit of all this stuff as h approaches 0, well, what's this stuff? Well, f of a plus h is really a plus h squared minus 4 times a plus h. That whole term is f of a plus h minus f of a, which is a squared minus 4a, all over h. Does that make sense so far? So now what I'm going to have to do is I'm going to expand all this stuff out. Cancel out some terms. I should have nothing but terms with h when I'm done in the numerator. I should be able to factor out an h, and then I will be able to plug in my 0 because I will no longer have h in the denominator, right? We've done this a lot of times. So let's expand this. What is a plus h squared? Can you guys say that off the top of your head? It's a squared plus 2ah plus h squared. Good. Then we've got to distribute 4 times the quantity, or negative 4 times the quantity a plus h. Now, if I forget one minus sign in this process, the whole thing goes wacky. Then I need to distribute the negative 1 through the brackets, which will be negative a squared plus 4a, all over a, or h, I'm sorry. And we're taking the limit of all that stuff as h approaches 0. All right? And let me zoom in here. So now at this point, every term that does not contain an h in it should cancel. If it doesn't, Mr. Adams made a mathematical error somewhere.
But you didn't. You're a wizard.
This is true. So now a squared minus a squared, those go away. Negative 4a, positive 4a. I have 2 terms left, and both of them have h's in them. So I'm going to say the limit.
3 terms.
Is there 3 terms?
2ah, h squared.
Oh, there's 3 terms. So now what I have is 2ah plus h squared minus 4h. Can you guys see that okay?
Yeah, it's all right.
All right.
Well,
Well, now you can't, right? So now what do I do?
you cancel out the h. Wait, you take out an h.
I've got to factor out an h in the top. So I'm going to say the limit as h. Oh, hey, you guys want to hear something funny? I can tell you the answer before I finish. It's going to be,
It's all right, it's okay.
listen, it's 2a minus 4. So anyways, here we go. So if I factor out the h, what I end up with is 2 times a plus h minus 4 all over h.
H is not.
The h's cancel. Well, they reduce to 1 over 1. And so now I've got the limit as h approaches 0 of 2a plus h minus 4. And I'm going to plug that in. So it's 2a plus 0 plus negative 4, which is...
A was 1.
A was 1. So now the slope of this whole thing, because that's what this means, is 2 times 1 minus 4, or the rate of change, which is actually equal to the slope of the tangent line at x equals 1 is actually negative 2. That was a lot of work, but you know what I figured out? And I should have wrote this in blue. I figured out that the rate of change, which is the slope of the curve at x equals 1, is negative 2. So now that I know that information, if I wanted to write the tangent line, I need 2 things. I need the slope, which we now calculated was what? Negative 2, and I need a point that goes through. What's the point that goes through?
1, 3.
1 comma negative 3. So if I do the point slope form, and remember Mr. Adams kind of amended it. I said that y is equal to x minus x sub 1 plus y sub 1. That my equation will be y equals negative 2 times the quantity x minus 1 minus 3. All right? So y is equal to negative 2x plus 2 minus 3, or y is equal to negative 2 x minus 1. Now, you might say, I don't know, Mr. Adams. You are a wizard, but what if you made a mistake? Well, I can verify it. Watch what happens. If I go in here and I say negative 2x minus 1,
Why'd you put that in parentheses?
for fun,
Okay.
and I graph it, boom. Now, where do you think those two intersect?
Maybe a 1 negative.
1, comma, negative 3.
Okay,
Wizardry,
shh.
wizardry.
That's what we wanted.
What is this?
But what about the normal line?
Oh, that's a good question,
The inverse.
my fair lady.
Inverse.
The normal line is calculated in what manner?
Inverse.
Yes, to do the normal line, my good people, what we will do is we will change the slope to the negative reciprocal of negative 2, which is a positive 1/2. Now, what point will that normal line per se go through?
Same point.
Thank you very much.
So it'll be the same thing.
Well, it'll be a little different, right? So, same thing though, I'm going to plug this into 1/2 times the quantity x minus 1 minus 3, distribute the 1/2 through the parentheses, so I get 1/2 x minus 1/2 minus 3. Now, that's really negative 3 and 1/2, which is the same as 7 over 2. So, it's negative 7 over 2, right? For those of you playing along at home, 3 over 1 is the same as negative 3. If I want to have a common denominator so I can add these bad boys, I just multiply this by 2 and multiply this by
I
2.
don't get to play along. I didn't pay their tuition.
Shh, I'm not done. So this becomes 2, this becomes 6. Negative 1 minus 6 is negative 7. You're welcome.
You're welcome.
You should really stop using orange.
Yeah.
You can't see it?
The orange is kind of difficult to see. You can see it, but
They
it's
don't get
kind
to
of
play.
Oh, I'm sorry, I didn't. It looks really good on my screen, but I'll use a different color.
Yes, you will.
I'm recording, by the way, so if you guys can keep some of those comments to yourself. So now let's graph this.
Don't mess up.
For those kids playing along at home who didn't pay their tuition.
Wizard.
They were nuts.
For the kids playing along at home. That's what they always say when you watch a television show. They'll say, for the kids playing along at home.
Never heard that.
Why don't you be quiet and leave me alone? So let's double check this. So we are going to say 1 divided by 2 times x minus 7 divided by 2 and graph it. Now, it doesn't look like a 90-degree angle, but we know that it is. This is just because the windows of the graph, that's not a perfect square. The graph isn't perfectly square. But it does intersect, and it is a 90-degree angle.
That really doesn't look like a 90.
Well, I mean, we could graph it by hand. I'm glad that you said that. So, no.
Whoa, no, don't think so.
You sure?
Yeah.
You trust me? All right.